In this biodemographic short, I consider what growth rate is required for 40-year-old men to have two 20-year-old wives. In a certain hypothetical primitive community, men marry at age 40 and women at age 20. How fast does the community have to be increasing for each man to have two wives? Assuming a stable population with men and women increasing at the same rates and equal numbers of boy and girl babies, the growth rate R needed is the solution to the equation given here, where L20 and L40 denote survival to ages 20 and 40 for females and males respectively. Assuming that sex-specific survival differences are negligible, a first approximation of this rate is ln2 divided by 20 equals 0.35, a value within 0.001 of the population growth rate, estimated using the age-specific survival rates of U.S. females and assuming male rates are identical. You can see this illustrated graphically here, where we have age on the x-axis and the fraction age x on the y-axis. Here is the age distribution of a replacement population, that is zero population growth rate, where r equals 0. In contrast to this older non-growing population, we see here a population growing at a rate of 0.35, a growth rate which produces a much more youthful age distribution. So we see here that there are 2% 20-year-olds and 1% 40-year-olds. Therefore, we have a 2-to-1 ratio of 20-year-olds to 40-year-olds, which, as a first approximation, would apply to 20-year-old women relative to 40-year-old men.